Hi. Was this like a question and answer format?
If you could just introduce yourself first, and then we can open it up for questions.
So hi, I'm Brian Kemp. I've been in the software industry for approximately, I think like 13, 14 years. So quite a long time. And I work at, yes, I can see you all waving in the back. I work at NASDAQ, which is a stock market, and I work on NASDAQ.com, the major website of NASDAQ. It's for retail investors. Before that, I worked at a trade show company doing online registration and on-site registration for handling large numbers of attendees coming to the show. And before that, I was a Penn State student at University Park. And I've been messing with computers pretty much all my life. So,
can you let them know how you got started?
Well, if I really want to know how I got started, it was probably about 10. I'd say I was 10. My father purchased a used Commodore 64, which is an absolute ancient system, but it came with a lot of schematics and books and how to program it and how each chip interacted with each other and how certain things worked. This is where the location and memory, where the characters were. This is how to do certain operations. And that was fascinating, absolutely fascinating. So I just started reading through the books. I remember only ever getting into machine language mode once by accident. And I could never do it again. And it made me sad. I still don't know how to do it.
So we're used to turning on the computer and having everything show up for us.
Yeah, this thing would just kick you into a prompt, said ready, and you were expected to know what to do.
Okay.
You had to read the books to figure out what was going on. I mean, it was pretty easy. You could plug something in the cartridge port, turn it on, or stick a disk in and say, load the first file from disk and call it a day. That was pretty easy to figure out. But you got thrown in. It was sink or swim.
So I have a question for you. You said you just throw a disk in.
Mm-hmm.
Okay. There are some 7-year-olds on the.
Oh no, a disk.
So you might need to tell them what a disk is.
I wish I brought a 5.25 inch floppy disk. It was, I think, USB flash drive, but long, thin, and it held very, very small amounts of data. It might hold a couple documents these days by today's standards. It was just,
trying to explain what it is.
About 5 inches aside, very thin, very easy to damage. But it'd be sort of like a very old SD card would be a good way to think of it.
Okay. Yep. So when you were starting, was the internet available to you? Just so we can kind of put some context to it.
94. In 93, my mother enrolled me for a course on how to use the internet. It was super early. A lot of the internet was text-based. I mean, there was some basic web browsing, but Gopher and things like that no one uses anymore. But I will tell you, IRC is still around. And there was a lot of things about chatting via the internet to strangers. And IRC worked great over the really, really slow modem connections at the time. We're talking like 2G or slower, really, really slow connections. But it was all text, so it was real time for us. And I remember spending a lot of my teenage years talking to people all across the country. I found a couple programs to write computer music, and we would swap files back and forth.
Okay. So I'm guessing what we could probably equate that to when you're talking about talking to people from all over the world, kind of like a Facebook, because it was an environment where you would connect with people, or a Twitter?
Not really like a Twitter wouldn't be right. It's more like a chat room.
Chat room?
Yeah, you could say Google Hangouts, but anybody could join.
Anybody could join. Okay.
As long as you knew the server network connection information, you could get on the network. And there would be various chat rooms, what we would call channels on IRC. Again, IRC is still around, so I'm still on it every day, but just different rooms. And so whoever joins, you can chat. People go, people leave.
Okay.
There's no real time. It's not like you're sitting there talking to somebody. There's not an expectation that they have to get back to you in these times. Like
you drop in.
Drop in, drop out.
Okay, so you learned how to program because of the old computer that you got, and you had to read and figure it out. You couldn't even look up on the Google.
There was no internet.
Yeah.
I mean, to be fair, those computers actually could connect to things what they call bulletin board systems, were like pre-internet type things. I didn't have that. I didn't have the hardware for it. So I couldn't even get on. So to figure out what it had to do, I was stuck with the books and anybody else I could talk to, which weren't too many people. It's not like you can just get on the internet and find a chat room or a Facebook group or something for a board that people are interested in a certain thing. They didn't. That didn't exist back where I was.
So then what kept you going?
It's just interesting. It was just fun. I mean, I hit a wall and then I would do something else. I mean, we still played a lot of games on that computer. We'll be honest. They're kids. We play games. We're kids. And then when I got the internet with the family computer we bought in 1995, that was just a whole world that opened up to me. If things weren't going so well for me in high school, I could hang out with these people who shared my interests. There maybe was a couple people in the school that shared my interests, but here they were all over the world interested in this one thing, and I could talk to them about that.
Okay, very good. And so you decided to go to school for computer science.
Yes.
And then can you tell us a little bit about your job?
Sure. First job out of school, I worked for a trade show company, and they put up a website and you would pre-register for the show saying, I'm going to go. And that was cheaper because people could know how many things to order in advance. If they had to order like meals for people, or if they had to order seating or negotiate deals with hotels, which they would often do, to know how many people are coming.
So it's a reservation system.
There's a reservation system. They actually added hotel booking later. And they could sell things like if you wanted to see somebody talk and there were only 300 seats, you could ticket all those seats and then you could sell them a ticket for $20. And when it hit 300 people, that was it. The ticket closed.
Okay.
So you could buy it early and reserve it and hold on to that. And then we could mail that information to you, like we could mail you tickets and your badge. You could just walk in the door. You wouldn't even have to stop and wait in line at registration. You were just done. You could go right to what you wanted to do.
So you made the people that went to the trade show, you made their life very easy by allowing them to check in online. And okay. And now what are you doing at NASDAQ?
At NASDAQ now I work on www.nasdaq.com, the retail investors website.
What is a retail investors website?
Retail investors means like your parents, basically. You and me, little people who don't work for an institution or a company. They're in the stock market because they either have investment vehicles like a 401k or retirement plan that depends on the stock market, or they actually have stock in their portfolio that they have purchased, and they want to keep tabs on it. They want news on what a company is doing, and that's going to influence whether people want to buy or sell the stock. That's going to, if they want to know things about dividends, they want to know things about how much the company is making.
Okay.
A dividend is the share of stock is like a small percentage of a company, and a dividend says, well, for every little share you have, I'm going to give you a little bit of money as part of that was our profits. So we're like, sharing our investment with you. It's a dividend. So if you own a lot of dividend stocks, you can basically get paychecks from it.
So what do you do with that website?
I make sure all the data on it is accurate. I make sure the news is coming in there so you can get the latest news quickly. That it doesn't fall over if there's a particularly busy season, what we call earnings season, when all the companies report their earnings. A lot of people get real interested in what those results were. So the site gets hammered. Have you ever heard Slash.effect, Reddit Hug, Digged, anything where people just hit stuff because it was got real famous on some site?
So it gets so popular that the
web server falls over. Yeah.
Okay.
We don't. That doesn't happen to us much, but my job is partly to keep that from happening.
Okay. And what kinds of things do you have to do?
Well, one of the things that I have to do is a lot of it is data optimization. How do I make things come in faster? How do I find the information that people want as quickly as possible?
Okay. So are we getting questions?
What problem? Okay, we do have a question.
Good. And as you get questions for Brian, you can add them to the chat. Yep. For those of you that have been visiting us daily, this is a different type of computer programmer, computer scientist that you're listening to today. So we had talked to some people that had made things for kids, and you were making things mostly easy for grown-ups. Yep. So what was
I've done some other projects, and I'll get into that. But
okay. Yep.
So we've got, what programs should we be learning to apply for web development jobs? The big one is figuring out how a web browser works, understanding a little bit about HTML and CSS. If you want to do something that's really interesting, pull up a web browser and hit F12, which brings up the web inspector. There's a couple other programs you can add, like Firefox has Firebug, but most web browsers, modern web browsers, have what they call the web inspector. And what you can do in that inspector is you can take some of that code that you can see, or you can see a property, or you can see how like CSS inheritance works, and you can make a change. It doesn't save it to the website. It just does it for your machine. But you can fill around and you can like change the text color, or you can make text large and small. Yeah, seriously. And we use the web inspector all the time, but that shows you how CSS works, so you can, or HTML works. So you can make little web pages and tweak it in the web inspector, and when you figure out the properties are right, you can go back and change it in your page.
Oh, okay.
So using the web inspectors and these kinds of things will definitely show you how to make like the front end web development work well. Back end, you're going to need to understand a little bit more about protocols and web servers. There should be some pretty easy, like build a web server distributions or programs. I mean, even something like Amazon Web Services, where you can spin up a virtual machine or give you a shared server time very quickly and just play with it. If you learn by doing, that's the best thing to do.
Okay.
If you learn by reading, then there are plenty of tutorials out there.
Okay. And if those are for more of the advanced
yeah, that's
people,
a little advanced.
Yeah. So some of us were working in code.org or with Hopscotch, and that's a really great place to start. But for those of you that are in high school, that's a good.
Oh yeah, play with the web inspector.
Yep. Okay.
They have things like the JavaScript debugging console too. So when because in code.org, you're writing JavaScript. You may be using the drag and drop interface, but if you ever hit that show the code, it's all JavaScript.
Okay.
And that's one of the biggest things, is that you might be using their, move forward API or whatever like that, but you're still writing the JavaScript. You're still writing the basic building blocks of code.
That's kind of cool. Okay.
So favorite part of my job, I've got 3 questions here. Favorite part of my job, when I get something working, like usually there's a fair amount of repetition, but every once in a while there's this weird problem. It's like, how do I make this faster? How do I make this bigger? How do I make this better? How do I make this scale? Like what I mean by scale is, if 3 people are asking for a page and it takes a couple seconds, who cares? But if 3,000 people are asking for the same page, it might take longer to serve all those requests. So you get particularly challenging problems, and the accomplishment you feel when you solve one of those really challenging problems is wonderful.
You know what? This isn't something that I heard it from we interviewed an 8th grader a few days ago, and he kind of looked the same way you did, and he was talking about how hard writing his program was, and he had a big smile on his face, and that's what he said he liked about it.
Yeah. When you get it to work, like I pushed the button, I made this happen. Like the first time your code compiles after you've been working with it for a while, that's fun. The first time it runs right, you're like, oh. Yeah. So there's an innate sense of accomplishment, a little bit of wonder. That's my favorite part of my job. The experience I working for code.org,
please report to the office.
I would go to different schools. I had elementary school kids, man. They ask really good questions. They will just pepper you with questions. I remember feeling that they were doing a programming exercise, and one of the things I told them was solve a maze. Solve the maze backwards, because you're one step away from the exit, right? So, and this actually gets into recursion. You're one step away from the maze exit. You know where to go. You just go right through the exit. But if you're 2 steps away, all you really have to do, you don't have to get to the exit. You just have to get to the 1 step away. So now you've solved the problem that from 2 steps away from the exit, you know how to get there. And 3 steps, you can solve that with 4 steps. So you can solve the maze backwards. And then that actually is what, it's a divide and conquer strategy. You're really solving a smaller problem and then expanding it into a bigger problem. And this happens a lot.
Yeah, and I know a couple of the classes that are connected have talked to their kids about debugging. So not debugging, decomposing. So that's kind of what you're explaining.
Right.
Take a big problem and break it down.
One of my favorite sorts, for example, if you have to sort a big list of papers, is what they call the merge sort. You split it in half.
Good afternoon,
Everything on one side and you sort it, and put everything on the other side and you sort it. And then the merging back together is
Something at the school store
because
tomorrow.
you have two lists of sorted numbers. It's easy to compare the ones in the top.
What a deal.
So it's called the merge sort. And so you take this big problem and you split it in half. So how long did it take me to make a web page like Code and Word? That was probably a month to a year project. That can take a large amount.
Science club.
You're working on it a lot every day. You're doing little pieces. Some of the pages on NASDAQ.com, it could take me a week or 2 weeks to build them because I'm building one page. I have a lot of already things I've built that I can build on top of it.
Today, December the 8th at 8 o'clock.
So there's that. As for the WYSIWYG editors at all, like front page, I'm mostly doing what I call backend, or what they call backend development. You take a bunch of data from some other source and you put it on a page. So I don't do a lot of formatting. We have web designers, and so what I'll do is I'll give them the structure so they can make it look pretty, because if you have something that's structured very well in HTML and CSS, it's a lot easier to make that look pretty to make something that's actually a mess. If you have structure, you can impose it. It seems like a weird thing, but that's the way web development works. And I never get any complaints. So I tend not to use WYSIWYG editors like from I'll just compile and run, deploy something to a web server and look at it and go, okay, that looks right. So I tend not to do what you see is what you get. It's not what I'm doing right now on .com so much.
So you worry about more of like the bones, and then somebody else worries about making it look pretty.
I put the bones together, I put the muscles on it, and somebody else does the skin.
Okay, thank you. That's a good analogy.
Yeah. As for my favorite web page that I developed, that would be the real-time quotes page on .com. I can even type that in. It would be something like this. That one. The charts. That took me months to get right because, and if you actually go through and poke through that code, you'll see it's actually 5 data sets. It is all this, everything above the previous close, the green, everything below the previous close, the red. Then you have the volume chart at the bottom and those high and low little orange data points are actually. And it took a while to get that right. The actual charting package is just a package called high charts. What you do in computer science is you take something that somebody else has made and you build on top of it to make it do what you want. You never start from scratch. Somewhere somebody else has done some of your work. So you can look at that page and play with it. That's just the real-time quotes for NASDAQ.com. But that chart is something I've worked on. And that took me a couple months to get right because there's things like the real-time updates. As you sit on the page, it will pull in more and more data. And getting that graph to look exactly like they wanted it was a lot of work.
So when you say that there's other people that have done everything and you don't have to start from scratch, that's kind of comforting to know. That
it's like science. You build on the shoulders of giants, as Isaac Asimov said. You have somebody else comes forward with a discovery and you take it further. Like you're never really starting from scratch. You know, like when you have a web server that you stand up an instance of, somebody wrote that web server. That's code that somebody wrote. It's not like you're starting with a bunch of circuits. It's not like they give you a bunch of copper and some boards and some tools and say, build your own machine. Like, no one does that. Okay, you might in college, but that's as a learning exercise, and you're still working with complicated components. Computer science is full of abstractions. It's like, below this level, I don't worry about it. Like, I have a table. I don't care what the table is made out of, but I'm going to stick my laptop on top of it if I know the table is sturdy, because abstractions leak. I mean, the table may not be sturdy. You don't care what the table looks like. You don't care what it looks like. All you're doing is you're putting your laptop on it. So there's always
so you stay focused.
Yes.
Yep.
All right. Best way to find a job in computer programming. I will say that out of school, like a lot of colleges, their big thing is that they want to promise people that they'll find a job. Like Penn State, for example, because that's a big place that a lot of people will go to school. A lot of their departments will help people find jobs. They'll have employers that reach out and say, excuse me, I want to find a place to work, or I want to find employees, I should say. And then they will give candidates and they'll give mock interviews. You can find stuff on the internet, like Monster.com and Dice.com are not a bad idea. LinkedIn's not a bad idea. But like I got a job at NASDAQ because some recruiter found my information online. My web page is very old, and I think my friend whose server I was hosting on, I think that server finally went away. But I was so easily found in Google, and I had a greatest copy of my website up there. People would call me and say, hey, you want to work for this company? And I'd go and interview.
So it almost sounds like you need to have a web presence.
Yeah, even if it's just like LinkedIn or Monster or Dice or something like that. You can call an employer, but I haven't done that.
And I think that that's important whether you are a senior in high school right now taking AP courses, or I know there's some 7 and 8-year-olds that are watching this. Your digital footprint is really, really important because like he said, he's not calling other places. They're calling him based on what they see on the internet. You have to be really careful the entire time. All the time.
All the time. It can be really frustrating. It's like, why doesn't this work? There's a story, or really a technique. It's called rubber duck debugging. And I have 3 cats at home, and I like to use the deaf one because she'll just sit there. And what I do is if I have a particular problem I'm really frustrated at, I will talk to my cat. I will be like, Persephone, I can't get this to work. And I go through what all the steps are. Remember, Persephone's completely deaf. She's like, I want food. She doesn't care. But the point is, because I am trying to turn the problem into trying to communicate it to somebody else, I'll often solve it just by asking my cat. It's not like she has a meaningful answer. She doesn't know that I'm supposed to use a tree here instead of a linked list or something like that. She doesn't care. But because I, get stuck in a mental block, and in the process of communicating it to somebody else, even somebody who can't hear, I can solve that problem a lot better. Or even just get up, make a cup of tea, and go, oh, that's what I need to do. Like we ran into a bug where certain articles from the news feeds that we get from our partners would come in, they would crash. And I was like, I have no clue why this is crashing here. And I got up and I made myself a cup of tea, and sat back down. I said, oh, it's crashing, and there's no way around it because I'd have to change the code and do another deployment. Because it's this call here, so that by the time it gets to this point, there's the bad code that's been put in is like way back there. So it's crashing here as a symptom, but it's not actually the cause. It's stuff like that where and you just get frustrated because you don't see something or you miss something. You have no clue. It's like it's supposed to work, but it doesn't, and that can be really frustrating. So you have that sense of accomplishment, but you also have that sense of frustration.
So it's okay to walk away and come
absolutely.
back to it, but persevering is really, really important.
Yeah, I mean, like a lot of people, like a lot of programs, not all of them, but a lot of them do some type of gaming. And the reason is like when you play any type of game, board game, sports, anything like that, like losing is okay. Like, yeah, if you're like in a ranked match or something, it's terrible. Or if you're playing in a league, yeah, losing's bad. But losing teaches you as much, if not more, than succeeding at something. It's like, oh, this failed. And being able to just, especially because computers, like especially in code.org, if you make a mistake, you just hit the reset button and you're right back to, you keep your code, but the state of the system starts right back where it was again, so you can go and fix that faulty instruction. So failing is okay because it's really easy. Like, say you're like shuffling a deck of cards before doing it. You have to shuffle the deck every time if you're trying to deal something out. Well, you just hit the button, the computer will do it for you. So getting back to that pre-failure state is a lot easier in computers. And so it's okay to fail as much as you want.
As long as you learn from it.
Your tech is dismissing for the day. You're welcome.
Okay. And we have been going for about a half an hour. Is that one more question?
There's one more.
Okay.
What kinds of things did I do with code.org? Well, I mean, I poked around with it because I went to a charter school in the city, in New York City. I don't remember which one it was off the top of my head. I think it was on King Street.
Lincoln.
Yeah, Lincoln. It was Lincoln. And I was helping the kids out. And so I had to do code.org myself. So I picked the ones for their age group and I walked through them myself. What was easy for me, again, and I explained this to the high schoolers that we talked to earlier, is that when you go to college for computer science, you don't learn how to code. You learn how to make a computer implement something or do a concept. You don't learn how to write the individual line that does it. It's like, I know how to make this happen, but I don't know how to do it in this language. So the hardest thing for me was getting over the interface to drag and drop code. Really. but it's like, okay, I have to move 3 blocks forward, like the Minecraft ones. I have to move 3 blocks forward, turn, and then do this. It's like, okay. It started to get fun with the loops. Before that, it was a little tedious.
Okay.
Loops are especially the 7 to 10. Like loops come in fairly early.
Yep.
And it teaches you a little bit about how to avoid repetition. Because before that, it's like move forward, move forward, move forward. And you're like, forget that. Make a loop and then move forward 3 times. And you write a lot less code because you're making the computer do more with what you write less. And the lessons build upon themselves. I would say the thing that was really interesting for me was the Frozen demo. That it's kind of Disneyfied up a little bit, but we were doing that stuff 20 years ago. The concept of the turtle, that's logo. Move forward, turn 90 degrees, and so those painting those lines, that brought me back to my childhood. So some of the concepts have been around for a very long time. The other one that I found really interesting in today's climate that I thought was really interesting was the Flappy Bird one. That one, it seems difficult at first, but what you're doing is you're not writing code, you're not writing instructions. What you're doing is you're writing what they call event handlers. When something happens, this gets called. What do I do? Like when the player touches a pipe. That's an event handler.
Okay.
So
is that like if then?
That's not even if then. It's like in this state of the game, something will happen. This event triggers.
Okay.
So when you touch a pipe, some code gets run, and you have to write that code. And like writing games and writing a lot of things like in JavaScript on web pages is all event handlers.
Okay.
So that's really good for if you want to learn web development. Play with Flappy Bird a little bit. I know that sounds really weird. But.
No, I think that's sound advice. Okay. Did we get that last question?
Yeah, that was what kind of things I did. I just basically walked through the stuff, and yeah, they've really got a decent, solid lesson plan.
Yeah.
Very much build on top of stuff. Just walk through it.
So our time here is just about up. I know that schools are starting to dismiss. That was very nice of Brian to actually join us today. So I know that he can't hear us, but we could still give him a hand for his time. Okay.
Just wave.
Yeah. Okay. Have a great day, everybody, and have a good evening. Bye.